We'll wait for 2 minutes. Okay, let others also join. Then we'll start the class. Yes, good evening. We'll wait for just 2 minutes. Okay, we'll wait for others also to join. We'll wait till 5, then we'll start the class. Yes. Okay. Yes. So good evening, students. So it's already 5. So we have waited for 5 minutes. So okay, so we'll start. We'll start the topic. So last class we have already started with the topic called as solutions. Okay. Yes. So what are solutions? So what did we discuss in the last chapter in solutions? Yes. What is solution? So solutions are what? Solutions are, it is a homogeneous mixture. So we have seen what are mixtures. So there are two types of mixtures, homogeneous mixtures, heterogeneous mixture, right? So this solution is nothing but we are studying completely about homogeneous mixture. So what is homogeneous mixture? It is made up of two or more component. Then it is called as what? It is called as solution. Okay. Then what is solute? Okay. So whenever the component is in very less amount, then it is said to be solute. Solvent, the component which is present in the larger amount, then it is called as what? Solvent, right? Then we are discuss about the type of solutions, right? Solution are also called as what? True solutions. Then we had discussed about the types of solution. So there are different types. So depending upon the nature of solute and solvent, there are solutions are classified based on gaseous solutions, then your liquid solution and solid solution, right? So we had discussed about the examples also, right? So we had seen the example, we had seen which is a solute, which is the solvent. Okay, what are the common examples? So you need to see this particular tabular. Okay, then we had started with the strength. Okay, strength of the solution. What do you mean by strength of the solution? It tells you about the concentration. Okay. Okay, so it tells you about the concentration. So we are expressing the strength of the solution in terms of their concentration. So we had seen about mass percentage, right? So mass percentage we had discussed. Then mass by volume percentage, then volume percentage. Okay, so these three we have discussed, the strength we have discussed. Then what is strength? So strength is nothing but when you dissolve. Okay, when you take amount of solute in grams, which is present in 1 liter of solution, is nothing but your strength. Okay, so depending on the strength, we have discussed about the molarity, okay, and molality. So how it difference molarity and molality? Yes, molarity is what? When number of moles of solute dissolved in 1 liter of solution. Okay, remember the main difference. Okay, what is the main difference? So when number of moles of solute dissolved in 1 liter of solution, then it is called as what? Molarity. Okay, it is represented by M, capital M, and M is nothing but molar. It is also said as molar. What is the formula? Moles, that is moles, number of moles of solute dissolved in 1 liter of solution. Okay, so that is for molarity. What is molality? Molality is what? Number of moles of solute dissolved in per kg of solvent. Okay, it is dissolved in what? It is dissolved in per kg of solvent. So this is represented by small m. Okay, it is represented by small m. What is the formula? So that is number of moles of solute dissolved in, okay, mass of solvent in kg. Okay, here it is taken in kg. So we have discussed about molality, molarity. Then we are discuss about the mole fraction also. Okay, so what do you mean by mole fraction? So that is the number of moles, okay, of one component to the total number of moles of all the components. So always how many components are there? Okay, sum of all the mole fraction is equal to 1. Remember that sum of all the mole fraction is equal to 1. So we are left with this parts per million, right? So we were discussing about parts per million. So what do you mean by parts per million? That is the number of parts of solute. Okay, number of parts of solute present in million parts, that is 10 raised to 6 of solution. So this is called as parts per million, that is ppm. Okay, what do you mean by ppm? ppm is nothing but parts per million. Okay, it tells you about the number of parts of solute. Okay, so this tells you about very small quantity. Whenever you are studying about ppm, okay, ppm, it tells you about very small quantity. That is, it is when ppm is used, that is ppm is used when you it is used to express the concentration. Okay, it is used to express the concentration of a solution where the solute is present in very small quantity or very minimum quantity. You know that always the two components, okay, that is a solute and solvent. So which is solute? Solute is one which has very less in amount. Okay, whichever is very less in quantity, it is called as solute. And solvent is what? Which will be in more quantity. Now ppm, when ppm is used, when ppm is used for calculating the strength or to express the concentration of solution, when your solute is in very small amount, that is in minute quantity. Okay, when your ppm, so when so remember that ppm, that is parts per million, is used to express the concentration of the solution when the solute is present in very minute quantity. Okay, so what is parts per million? That is, it is the number of parts of components per million. Per million means what? 10 raised to 6. Okay, per million parts means 10 raised to 6 of the solution. So how it is represented? It is represented by ppm. Okay, it is represented by small ppm, that is parts per million. So what is the formula? Number of parts of component, or you can take absolute. So number of parts of component divided by total number of parts of all the components in the solution. Okay, so number of parts of component divided by total number of all the components in the solution into 10 raised to 6. Okay, into 10 raised to 6. So this is about ppm. Okay, this is about ppm. ppm, will solve one question, then we'll come to know about ppm. Okay, so okay, just so the question is a liter, okay, a liter of seawater, a liter of seawater, that is weighs, it weighs how much? It weighs 1030 gram. Okay, it contains about 6 milligrams. Okay, 6 milligrams of dissolved oxygen. Dissolved oxygen. Express the concentration. Express the concentration of O2 in ppm. Okay, in ppm. So what did I say? So when ppm is used, always when parts per million is used, when you have the solute. Okay, solute is present in very minimum quantity. Okay, very minimum or minute quantity. Now how do you calculate parts per million? That is number of ppm, that is parts per million of what you have to find of dissolved oxygen. Okay, of dissolved oxygen. So you, what is the question asked? Express the concentration of O2 in ppm. So number of ppm of O2 is given by, what is the formula? Mass of dissolved oxygen, mass of dissolved oxygen divided by total mass of all the components. Okay, or total mass of the solution. So in this, into solution into what? 10 raised to 6, right? Into 10 raised to 6. Now, what is the mass of the dissolved oxygen? Yes, what is the mass? It is 6, right? 6. So it is okay. 6. We are expressing in what? So it should be 10 raised to minus 3. Okay, 6 is into 10 raised to minus 3 divided by what? Total mass of the solution is what? 1030 grams. So it is 1030. So into 10 raised to 6. So what is the answer? Just see, calculate and see what will be the answer. What will be the answer? So this is the way you're going to solve it. Okay. Yes. What answer you're getting? Just like yes. Did you solve? What is the answer you're getting? Okay. It comes to 5.82 ppm. Okay, it comes to 5.82 ppm. So this is the way you're going to solve. Okay, this is the way you're going to solve. So this is about ppm. So now we have seen all the concentrations. Okay, so always the concentration of the solution. Okay, so what do you mean by concentration? So concentration of the solution, okay, it is what? It is nothing but the amount of solute which is present. Okay, it is the amount of solute which is present in the given quantity of solution. So it always tells the amount of solute which is dissolved in the okay, more quantity of the solution. So these are the different ways in which you can express your concentration. So which are the different terms you have studied? Mass percentage, volume percentage, then mass by volume percentage, then parts per million, okay, then molarity, okay, molality and mole fraction. Okay, so these are the what? These are the terms, okay, the way of expressing the concentration of solutions. Now, based on this, we'll solve some questions. So we have already seen all the terms. So we have seen one question on parts per million. So now we'll solve a question on mole fraction. Okay, mole fraction, you know how to okay, mole fraction. So just see the question. Calculate the mole fraction. I hope you are writing down. Okay. Calculate the mole fraction. Calculate the mole fraction of ethylene glycol. So these are your in-text question. Okay, in from textbook only these questions are there. So for exams, they can ask you from textbook. So you need to solve these. Okay. So write down. So solution containing 20% of ethylene glycol, okay, by mass. So what is asked? Calculate the mole fraction of ethylene glycol. Okay, they have asked to calculate the mole fraction. Okay, they have calculate. So they have asked you to calculate the mole fraction of ethylene glycol, that is C6H6O2. Okay, it is C6H6O2. So it will be like this. Ethylene glycol means OH, OH. Okay. Okay, so these are diols. It is a diol. So that is, it is called as ethylene glycol. So it is what? C6H6O2. So calculate the mole fraction of ethylene glycol in a solution containing 20% of ethylene glycol by mass. Now, how to calculate this? How do you calculate mole fraction? Yes, what is the formula of mole fraction? We have already seen this mole fraction. Mole fraction is equals to what is this mole fraction is what? Mole fraction of any component is what? Number of moles of component, right? Number of moles of component divided by total number of moles of all the components, right? So this is about your, this is the mole fraction. Okay, this is formula for calculating mole fraction. Now what they have asked? They have asked to calculate the mole fraction of ethylene glycol in a solution containing 20% of ethylene glycol by mass. Now what, what do you mean by that? 20% of ethylene glycol by mass means 20% of ethylene glycol by mass, okay, means what? 20 grams of ethylene glycol, okay, 20 grams of ethylene glycol is dissolved in how much? Percent means what? You have to take by 100. So 20 grams, if you remove 20 from 100, it is left in how much? It is dissolved in 80 grams of water. So 20%, this statement, 20% of ethylene glycol by mass means 20 grams of ethylene glycol dissolved in 80 grams of water. Okay, 20% means it is out of 100. So out of 100, if 20 grams is ethylene glycol, remaining will be your water. It is dissolved in water. Okay, now you have to calculate what? You have to calculate the number of moles. This you have to calculate. So number of moles of what? Number of moles of glycol first. Okay, number of moles of glycol is what? It is expressed by this. Glycol is how much? So, okay, the number of moles is 20. Okay, divided by the mass. So mass, how you will calculate? So, you know, hydrogen, each hydrogen is 1, oxygen is 16, carbon is 12. So after you calculate, it will be 62. So this is 20 gram, this is 62 gram per mole. Okay, so you have to divide by the this. Okay, that is the mass by the molar mass. Okay, so now number of moles of glycol is given this. So after solving this, what you get? What is the answer? It will be 0.32 mole. Okay, solve and see, you will get 0.32 mole. Similarly, now this is for what? This is for glycol. Now you have to calculate for what? Again, so this is a solute. Now, which is a solvent? You have to calculate for solvent now. So number of moles of which is a solvent? Water. So number of moles of water. Okay, how do you calculate? N water, okay, is equals to how many grams out of 20% means out of 100, 20% is ethylene glycol. So it is 80 grams. Okay, 80 grams divided by what is the molar mass of water? Molar mass of water is 18, right? H2O. H2O. Calculate the molar mass 16. And this is each is 1. So 16, 17, 18. So 18 gram per mole. Right. So gram get cancels and you get what? The answer comes to 4.44 mole. Okay, it comes to 4.44 mole. So what is the first step? First step, you have to find the number of moles for each component. Now, in this particular ethylene glycol by mass, okay, there is ethylene glycol which is dissolved in water. Okay, water is a solvent and this glycol is your solute. So what you are going to do, you are going to find the mole fraction for each component. After you take for each component, so then what you have to do, you have to calculate the and now you have to add this in your this formula. Okay, so I'll just erase this part. Question. I hope you have written the question. Okay. Okay. So now here the number of moles. So each individually we have found out the components. Now what you have to do? Now you have to find the mole fraction. Okay, the mole fraction for, so mole fraction of what they have asked? Mole fraction of ethylene glycol. Okay, mole fraction of glycol is, what is the mole fraction? How it is given? So X, okay, X glycol is equals to, So that is number of moles of component. How much is the number of moles of components of glycol? That is G glycol divided by Ng, the total components. Okay, the total components like this. So, okay, what is the number of moles of glycol is 0.32 divided by 0.32. What is the number of component of water molecule? 4.44. So just see what you are getting answer. Simple addition. Just see what answer you're getting. You need to respond, okay? Don't sit idle. Respond to the questions asked. If you have any doubt, you have to stop there and ask, okay?
3.60.
3.60.
3.60.
See what you have to do.
10 to the power 2.
See, first you add 0.32 plus 4.44. Okay, it comes to 4.96 here. Okay, it comes to 4.96. Okay, and then so see, you can use a simple calculator, right? For in exam. So you start practicing with simple calculator. Yes, now you see easy way. Just add first. Okay, this you have to add first. Add this first. Then you divide 0.32 divided by 4.96. Simple calculators, you if you don't have simple calculators, buy simple calculators. Okay, for chemistry, physics, you can use simple calculators. No scientific one. Simple calculators can be used for solving the problems. Now you can tell me what is the answer.
0.06, ma'am.
Yes, 0.0678. Okay, so this is the answer. Did you understand these two problems? Will proceed further, or I should explain it again?
Ma'am, which type calculating number of moles of glycol? Once again explain, ma'am.
Number of moles of glycol.
Yes, ma'am.
Okay. See, now what is the formula? Formula is what? Mole fraction is, how to calculate mole fraction is number of moles of each component. Okay, each component divided by the total number of moles of all the components. Now, what is the question asked? The question was to calculate the mole fraction of ethylene glycol. Now, ethylene glycol, how much is there? The solution consists of 20% of ethylene glycol. 20% means what? 20% is 20 divided by 100, right? Means out of 100, 20% is your ethylene glycol. Now remaining 80% is what? Ethylene glycol solution means what? Ethylene glycol solution is prepared in water, right? So ethylene glycol is 20%. So remaining 80% is what? Is your water. So number of moles. So whenever you are, so number of moles of components, how you have to calculate number of moles of component? That is this what? Just a second. Okay, I'll just add. Okay, so ethylene glycol, so it will be what? Don't take it as C6H6O2. Okay, I had given the formula, right? You cancel it from there. So the formula I had written, right? CH, CH, OH, H, OH, right? So how many carbons are there? C2, H, 1, 2, 3, 4, 5, 6, H and O2. Okay, so calculate the molar mass. So whenever you want to calculate the number of moles of glycol, glycol means how to calculate number of moles of glycol. Okay, that is how many this is taken. It is 20 grams. So 20 grams of ethylene glycol is present. Okay, so that is 20 grams divided by the molar mass of ethylene glycol. What is the molar mass? So carbon, the mass will be 12. Okay, then hydrogen is 1 and oxygen is 16.
Ma'am, 110 will come. 110.
No. Just see. ethylene glycol. How many? See, 1, 2, 3, 4, 5, 6. 2 carbons, 2 oxygen. Now 12 into 2. Okay, plus 6 plus 16 into 2. It will be 62. See, carbon is 12. 12 into 2 carbons plus 6 into 1. Each hydrogen is 1. Right? Plus 16 into 2. Each oxygen is 16. See, did you get?
Yes, ma'am.
Understood? Yes. So here, see here, if you are still did not understood, see here, 12 into 2 plus 1 into 6 plus 16 into 2. Okay, it comes to 62. So you have to divide it by its molar mass. So this is the number of moles of glycol. Then number of moles of water. So out of 20%, 80% is of water. So 80 gram divided by its molar mass of water is 18. So this comes to 4.44. Now what is the formula? Number of moles of component. Now what they have asked in question, it is they have asked for the, you have to calculate the mole fraction for ethylene glycol. Okay, ethylene glycol only they have asked, means you have to add number of moles of component means of ethylene glycol. So you have to take here 0.32. Okay, so the mole fraction of ethylene glycol is number of moles of glycol divided by number of total moles, that is glycol plus water. Okay, so it comes to 0.32 divided by 0.32 plus 4.44. Okay, so after solving this, so solve it at each step. Okay, don't hurry go to the conclusion. So each step, so now you add this first. Don't directly go for dividing. So 0.32 plus 4.44, add it first. Then you divide it. Okay, then you will get the proper answer. So this is the way you are going to solve the mole fraction problem. Understood? Mole fraction. Okay. So next we'll see molarity. One problem on molarity. So calculate the molarity of solution containing 5 grams of NaOH in 450 ml of solution. Okay, so this is the question. Okay, so what is molarity? Yes, can anyone tell me what is molarity? What is molarity?
Number of moles of divided by 1 liter of solution.
Dissolved in 1 liter of solution. Yes,
Solution.
number of moles of solute dissolved in 1 liter of solution. Okay, and molality is dissolved in 1 kg of solvent. 1 kg of solvent. Okay, so this is the difference between molarity and molality. So now we are discussing about molarity. So we'll do this problem first. So the number of gram solute is given as what? 5 grams. Okay, so molarity, first we'll write the formula. So first we'll write the formula. Okay, molarity is equals to number of moles of solute, okay, divided by volume of solution taken in ml. Okay, that is in divided by into 1000. Okay, into 1000. So into 1000. So this is the you're going to solve now. So now, so number of moles. So calculate the molarity of solution containing 5 grams of NaOH in 450 ml of solution. So find the number of moles first. We have to find first what number of moles. Yes, we have to find first this number of moles. So number of moles. Okay. So number number of moles of NaOH. NaOH. How much? How to calculate number of moles of NaOH? How much grams it is? It is 5. What is the divided by mass given divided by the molar mass? Okay, what is the molar mass of NaOH? NaO and H. Yes. Na is 23, oxygen is 16, hydrogen is 1.
40.
Yes, 40. Okay, so the number of moles of NaOH, it is a mass given, that is 5 grams. Okay, 5 grams divided by the molar mass is 40 grams per mole. So gram get cancels and you get what? 0.125 mole. So this is the number of moles of NaOH which is dissolved. Now, okay, now you substitute in this particular formula. You substitute. So the number of moles, okay, number of moles is given as 0.125 divided by the volume of solution in ml. How much solution is given? It is 450. Okay, 450 ml into 1000 ml ml per liter. Okay, 1000 ml per liter it is. So this ml and this ml get cancelled. Solve this. So what you have to do first? So first you do 0.125 divided by 450. First you take 0.125 and divide it by 450. How much you will get? Just see. 0.125 divided by 450. Yes, how much you are getting?
0.277.
0.000277. Okay. Then into 1000. Okay. Into 1000. You get 0.277. Okay. Mole per liter. Mole per liter. So this is the way you're going to solve. This is the way you're going to find. So this is the molarity. So this is the molarity problem. Okay, so this is the molarity problem. I hope you have understood this. We'll proceed further. Yes. Others also need to speak here. I should understand that others are also understanding the problems. Yes. Okay, so we'll go for the next one. Molality. So we'll see a problem on molality. So take down the problem. So calculate the molality. Calculate the molality of 0.5 grams of 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 ethanoic acid that is CH3COOH in 75 grams of benzene. Okay. So this is the problem of molality. Okay, molality. What is molality? Yes, molality, small m, is equal to number of moles of solute, right, divided by mass of solvent in kg. Okay, or kg, or this is the smallest unit you have to take. So they have taken in grams. Okay, into 1000 kg per kg. So this is the formula. Okay, this is a formula. Now what you have to do? Now first thing is what to do. Yes, now you have to tell me. First thing what you have to do.
Molar mass, ma'am.
First you have to find what? Yes, what you have to find first? Number of moles, right? We have to find first what number of moles. So now number of moles, how you will find? Now someone should tell me. Number of moles of what? Ethanoic acid. Ethanoic acid, yes. So how do you find it? Yes, calculate. You should also calculate the. Yes,
60, ma'am.
huh. 60 is the molar mass. What is the number of moles of ethanoic acid is given by 2.5 grams is given divided by what is the molar mass is 60, right? Into 60 gram per mole. This is gram. So gram get cancels and you get what? What is this answer? 2.5 divided by 60. How much will get? Yes, 2.5 divided by 60.
0.041.
0.0416. Okay. So mole. Others are not answering. Only one girl should answer. Yes. I want answers from everyone. Okay. So 0.0416 mole. So this is the number of moles of solute. That is for ethanoic acid. Now you have to, what you have to do? You have to take this formula and add in that. Okay. So m is equals to small m. What is the number of moles of solute? 0.0416. Okay. That is mole. Divided by how it is dissolved in how much grams of benzene? That is the mass of solvent is 75 grams. Okay. Into 1000 per kg. So what happens? Your gram and this gram get cancelled. Yes. What you do? 0.0416 divided by 75. Yes. Harshita. Answer. 0.0416 divided by 75. 0.0416 divided by 75. How much you are getting? Harshita, you are there? Now I'll take each one's name. That time only you have to answer. I should understand now you are there or no. Yes. Harshita. Yes, Jyoti has answered. The correct answer is 0.554 mole per kg. So this is correct. Okay, so this is correct. So, so this is the problem for molality. I hope you are understanding the problems. Problems are very important. Okay, so these are from textbook. Okay, these are from textbook, very important from exam point of view. So you need to write them. Okay, don't just simply sit. You have to attend the classes properly. Okay, you can take a small simple calculator and write down the things which I'll be solving. Okay, so next we'll go for the next problem. So we'll solve a problem on mole fraction. Okay, calculate the mole fraction of benzene in the solution containing 30% 30% by mass in carbon tetrachloride. Carbon tetrachloride means what? CCl4. Okay, it is also a solvent. CCl4, carbon tetrachloride. Tetra means tetra. Why it is called as tetra? Because there are 4 Cl carbon atoms. Okay, so tetrachloride. So calculate the mole fraction of benzene in the solution containing 30% by mass in carbon tetrachloride. Now, who will answer? Meghna. Yes. What do you mean by 30% by mass in carbon tetrachloride? Meghna. 30% by mass in carbon tetrachloride. What do you mean by that statement? 30% by mass in carbon tetrachloride. Yes. What do you mean by that? Hmm? Yes, who wants to answer? Others? Anybody who wants to answer? So 30% by mass of carbon tetrachloride means 30% out of 100%, 30% will be carbon tetrachloride, and 100 minus 30 is 70. So 70 will be your benzene. Okay, it will be your benzene. So 30% by mass in carbon tetrachloride means out of 100%, 30% will be your carbon tetrachloride and 70% will be your benzene. Okay, so this is the meaning of the word 30% by mass in carbon tetrachloride. Okay. Now, what is the first step? Yes, what is the first step now? What do you have to do? What is mole fraction? Mole fraction is given by number of moles of a component divided by the total number of moles of all the components. So first step is what? Nagalambika? Yes. See, I want everybody should answer. Okay. If you are not understanding, you have to ask. So, what is the first step? Jyoti, you're there? You can answer.
Number of moles of the molar mass of the carbon tetrachloride, ma'am.
Yes, first you have to find the number of moles. Okay, first you have to find the number of moles. Now, how do you calculate number of moles? First, you calculate for number of moles of each component. First, we'll start with benzene. Okay, first we'll start with benzene. Now, calculate the mole fraction of benzene in the solution containing 30% by mass in carbon tetrachloride. Means what? Out of 100%, okay, 70% is your carbon tetrachloride and 30% is your benzene. 30% is your benzene. Okay. So now number of moles of benzene. So benzene, how much it is? 30 grams. So 30 grams divided by what is the molar mass? Molar mass C6H6. Yes. 12.
180.
C6H6. Benzene is C6H6. Each carbon is 12. 12 into 6 plus 6 is equals to how much? Benzene. This is your benzene. Right.
78.
Yes, it is 78. So it is 78 gram per mole. Okay. So what is the answer you are getting? So you should get
0.38.
0.384 mole. Okay. So this is for your number of moles of benzene. Now number of moles of CCl4. Okay. CCl4. So out of 100, 80, 30 is benzene, so 70 is CCl4. 70 grams divided by what is the molar mass of CCl4? Okay, carbon is 12 and each
154, ma'am.
yes, and each chlorine is 35.5. So 35.5 into 4 plus 12. So it comes to 154 gram per mole. Okay, so gram get cancels. What is the answer? 0.4545 mole. Okay, so this is the answer. So this is the number of moles of benzene and number of moles of carbon tetrachloride. So number of moles of benzene. So I'll just erase everything and okay. So I'll write here. So number of moles of benzene is how much? It is 0.384 mole. And number of moles of CCl4 is how much? 0.4545 mole. Okay, so this is the uh, first step. Now, mole fraction of what they have asked? Mole fraction of benzene. So mole fraction of benzene. Okay, so how do we calculate mole fraction of benzene? So number of moles of benzene, okay, number of moles of benzene divided by total number of components, that is C6H6 plus your number of moles of CCl4. So it will be what? Number of moles of benzene is 0.384 divided by 0.384 plus 0.4545. Yes, what is the answer you are getting? So you're finding the mole fraction of benzene. Okay. So mole fraction of benzene is what? Hmm? Yes. You have to answer 0.384. You add for 0.384 plus C. What you have to do first? You add this two first. 0.384 plus 0.4545. What it will come? Okay, first you add this two. Then you have to, so it comes to, just a second. Yes, Meghna, your answer is right. So 0.3, 384 plus 0.4545. It comes to 0.8. See here, it comes to 0.384 divided by 0.838. Now you divide this you will get to 0.4583. So this is the mole fraction. Okay. So this is the mole fraction of benzene. Now, if I want to calculate the mole fraction for CCl4, how will you calculate the mole fraction for CCl4? You know the statement sum of all components, right? Sum of all component in mole fraction is equal to what? It is equal to 1, right? What did I give the statement? What did I give the statement? Sum of all mole fractions, right? The sum of all mole fractions is equals to 1. So remember this. Now, sum of all mole fraction is equal to 1. So that is, you know now, you want to find for what? CCl4, right? So if you want to find for C, sum of all means what? Means sum of mole fraction of CCl4 plus some mole fraction of C6H6 is equals to 1. Now you know the mole fraction of C6H6. You don't know for CCl4. So how you will calculate CL4 equals to 1 minus C6H6. Yes. So solve this. 1 minus 0.4583. Answer comes to what? What your answer comes to? Yes, Meghna, your answer is right. So it is 0.5417. Okay, so remember that. So first step, so mole fraction is nothing but number of moles of each component divided by the total number of all the components. First step is what? You have to find the number of moles of each component. Then you have to calculate the mole fraction for whichever they have asked. If you want to find out the mole fractions for other component, remember that the sum of all the mole fraction is equal to what? It is equal to 1. Okay, so you have to remember this and see, you know the mole fraction of CCS6. So you have to do minus. Okay, 1 minus that, you will get the mole fraction for CCl4. So like this, you are going to solve for mole fraction. Okay, then one more will solve on ppm. A small question is there on ppm that will solve. Okay, yes, ppm. Then two more are there that we can solve in the other class. Now a small question I'll take. A sample of drinking water, a sample of drinking water was found to be contaminated. Contaminated means what? The water was spoiled, okay, with chloroform. So drinking water, it had some chloroform. Chloroform is what? CHCl3. Okay, CHCl3 supposed to be carcinogenic. Carcinogenic means hazardous for the human body. Okay, carcinogenic. Carcinogenic means it is hazardous. Hazardous means it is bad for human body. Okay, if you drink such water, there are chances that you may feel you will fall ill, or it will cause some severe hazardous problem. Okay, so this is about the level of contamination. So after that, the drinking water was mixed, it was contaminated with chloroform, it was supposed to be carcinogenic. So the level of contamination was 15 ppm. Okay, so what you have to express? You have to express this in percent by mass, and second is determine the molality. Determine the molality of chloroform CHCl3, okay, in water sample. So these are the two questions. Okay, so first you tell me how you will tell 15 ppm of solution by mass means 15 ppm of solution by mass means what? What do you mean by this statement? 15 ppm of solution by mass. 15 means 15 grams of CHCl3 is dissolved. Okay, it is dissolved in 10 raised to 6 grams of solution. So you know, right? ppm is what? It is calculated like this. So 15 grams of CHCl3 is dissolved in 10 raised to 6 gram of solution. Okay, now mass percent. How do you calculate mass percent? Mass percent is mass of solute, okay, divided by mass of solution. Mass of solution, right, into 100. Now mass of solute is what? Mass of solute is how much gram is dissolved? It is 15 grams. So 15 grams dissolved in mass of solution is 10 raised to 6 grams. Okay, 10 raised to 6 grams into 100. Right. ppm means what? Small amount of this is dissolved in more amount of this. Okay, minute. So after solving this, you will get 1.5. Okay, it comes to, just a second. So the answer I'll write here, it comes to 15 into 10 raised to minus 4. Okay, you have to express in terms of percentage. So it will be 1.5 into 10 raised to minus 3. Okay, so I'll solve this question once again. So we'll stop for the day. I hope you have understood the remaining problem. This problem, I'll solve it in the next class. Okay. I hope you have understood the molarity, molality, mole fraction problems. Okay, ppm problems. The remaining problems we'll solve in the next class. Yes, any doubts you have to ask there itself. Okay. Any doubts? And others also please reply. Okay, you have to answer. Okay, then we'll thank you. We'll stop it for the day. Okay, thank you.